Hi, I'm Alistair, and in this video I'm going to give a beginner's crash course into pneumatics. Now, you might be familiar with pneumatic tools like a tyre inflator, a nail gun or a paint spray gun, but I'm going to be looking at building customised pneumatic systems, props, special effects and creative projects with moving components that are powered by air rather than electricity. So a typical pneumatic setup has a few key components. You've got a compressor, which is your main power source. Then you might have a regulator to control pressure, and various tubing and connectors, splitters and manifolds that branch the air out into a network. Then you've got valves, which can be activated to allow or stop air from flowing in certain sections of pipes. And finally, cylinders, which are what perform the actual movement. So you can think of it a lot like an electrical circuit, but instead of electrons flowing, you've got air flowing around the network. So I'm going to look at each of these components in turn, and because I'm more familiar with electronics, and I think many of you watching are as well, I'm going to use that comparison to components in an electrical circuit to help explain what everything does. So first up, the compressor. This is the power source of your system. It uses an electric motor to draw in air and compress it in this storage tank, increasing its pressure. It's then stored there for as long as required. When the pressure in the tank drops, the motor automatically kicks back in to refill it, so you've got a constant source of compressed air available. So let me show you what happens when I turn my compressor on. So you can see the motor starts up at the back, that's drawing in air, compressing it and storing it in the tank. And this gauge on the front tells us the pressure of the air that is currently being stored. So you can see the needle rising. And one of the slightly complicated things about working with pneumatics is dealing with all the different units of measurement that are used. So air pressure can be measured in pounds per square inch or PSI, but it can also be expressed in bars or kilopascals or kilogram force per centimetre squared. And what you'll find is that the dials on the front of compressors and regulators will use many of these different units. So the compressor I'm using here is rated for 7 bars. It's going to fill up the tank until it is full of air at 7 bars, and then it's going to automatically cut off. So once the air has reached the required pressure in the tank, the motor turns off and it is now stored and available for use, but it's completely silent at this point. I can even disconnect it from the electricity if I want to, carry this around, and I've got a portable store of compressed air. And then I can plug in a cylinder, a valve, or anything I want to direct that air into this socket at the top, and I can just start using it. And again, it's still completely silent because I'm using up the already compressed air. There's no electrics required at all to run this circuit at this point. And you could run that for quite a long time. It's going to take me quite a long time, but instead I'm going to plug in an air gun directly into the port here just to run through that air a bit more quickly and show you what happens when the air pressure drops below a certain value. On this compressor it's about 4 bars. What will happen is that the motor will automatically kick in again and re-pressurize the tank until it reaches its target value of 7 bars again. Now, when comparing compressors, there are a couple of different metrics to look at. The first is the pressure at which it stores air in the tank. So this is equivalent to the voltage of a battery in an electrical circuit. This compressor here stores air at 7 bars, which is about 100 psi. And that's a very common value for compressors of this kind of size, and it's going to be perfectly adequate for the vast majority of systems. You might actually have some outputs that need a lower pressure than that, but that's fine because you can always reduce it by introducing a regulator into your pipeline anyway. The second metric is the flow rate, which is how much air the compressor can deliver per minute. So this is more like electrical current, and it's measured in cubic feet per minute or sometimes litres per minute. A compressor with a larger flow rate will be able to supply air to more simultaneous outputs. Then you've got the overall size of the tank. So this is like the capacity of a battery. Compressors with a higher flow rate also typically come with a larger tank because they're going to get through the air faster. This is a tank of 20 litres, which is about 5 gallons. And this is sort of on the small to medium end, I guess, but I've still found it perfectly adequate to power about 5 simultaneous outputs, which is enough for most of the projects I make. Then you've got the motor power. So the power of the motor is measured in watts or horsepower. A more powerful motor means that it will be able to repressurize the air in the tank faster when it starts to get used. So a lot of the time these specs are kind of correlated. Having a greater flow rate means you'll want a larger tank and also a more powerful motor to be able to refill that tank. But bigger isn't always better. More powerful compressors are noisier, they're bulkier, they're more expensive. So this one here, this is a kind of a mid-range compressor. It's got a 20-litre tank, like I said, 7 bar pressure, and it's also really quiet. So I found this absolutely ideal for my needs. You can always start with a compressor on the smaller side and then add additional compressors into your project or buy a larger one at a later time if you need to upgrade. So you've got a tank full of air that's compressed at a certain pressure determined by the compressor you're using. But maybe that's not the same PSI that you want to run your outputs at. Or maybe you've got several different props that you want to run at different pressures from each other. And that's where regulators come in. So a regulator is an adjustable valve that lets you reduce pressure in different parts of the system. You can think of them as like a step-down voltage converter to ensure that you don't blow out a prop by feeding it too much air. Now, every pneumatic element will be rated for a certain PSI range. So this cylinder, for example, I don't know if you can see that, but that says that it is rated for between 0.1 and 0.85 megapascals. So I can insert a regulator into the tubing before that and set it to ensure that the pressure doesn't exceed that value. Just like you wouldn't want to plug 24 volts into a 12 volt electronic prop. Now, to connect that regulator as well as any other pneumatic component, you're going to need some tubing. So tubing is a pneumatic system's wiring. You can get tubing in different diameters, colours and made of different sorts of material. Polyethylene is one common sort of tubing, and that's cheap and easy to get hold of. Its only disadvantage is that it kinks if you bend it around a tight corner, and that's going to constrict the airflow. So if you use polyethylene tubes and you want to go around a corner, you'll have to get a dedicated bend connector at 90 degrees or any other angle. This is polyurethane tubing, which costs a little bit more, but it doesn't kink in tight bends. It's a little bit more rigid. Now, tubing is available in both metric and imperial sizes. You can get a 1/4 inch, 10mm, 6mm, 3/8 of a whatever. Wider tubing carries more air, but it's more expensive and it's a bit harder to manipulate and route. So I've chosen to use 8mm diameter tubing as my kind of standard. It's somewhere in the middle of the size range, and you'll probably find it easier to choose one size of tubing and then just stick to it, because then you'll know that everything will be interchangeable between your different connectors. And that brings me on to connectors. So every pneumatic component in your system will need connectors to attach it to your air tubing. And one thing to be aware of is that these connectors are not integrated into or necessarily supplied with the component. They're separate. So for example, here's a brand new solenoid valve, and if I open the packet, you'll see that I actually can't directly connect an air tubing into this. I'm going to need a connector that both matches the diameter of the tubing I want to use and also the threads of the ports on the component itself. Now, in terms of the end that matches with the tubing, you can get a couple of different styles. You can get a barbed style connector like this, but these are not great. You simply push the tube onto the end of them, but under high pressure that tubing can just pop right off again. it's much better to use a push-in style connector like one of these. So with these, you simply push the tube in the end and it creates a really sturdy airtight seal. To pull the tube out again, you push in this blue ring like this and then simply pull the tube out. And then you need the other half of the connector to mate with whatever component it is you're trying to connect. So for example here, I've got a cylinder and the cylinder has got ports with an M5 thread. So to connect my 8mm tubing into this cylinder, I need to use a connector like this. So this has 8mm push-in connector on one side and a 5mm thread on the other. And then I can just push in my tubing like that and it's connected. Now the valve which I just opened, this has a 1/4 inch port here. So instead I need to use a connector like this. Now once again, this has got 8mm push-in connector on one side of it, but this time it's got a 1/4 inch thread on this side, which means I can just thread it into there and now push my 8mm pipe in that instead. But annoyingly, if I show you this side of it, you'll see that it's got a mixture of some 1/4 inch threads and some 1/8 inch threads. So I also need to use a different connector type for the exhaust ports there. And you can also get completely different sorts of connector types too. The outlet from your compressor is most likely a Euro quick release connector like this, and you'll need a tube with a Euro quick release to mate with it. But there's a ton of other profiles that it could be. So you'll end up needing a ton of these little connectors with different thread sizes and whatever push-in size on this side you are using for the tubing you've chosen. Now one thing you should do before screwing a connector into a component is wrap a little PTFE tape around the end. So this is a very thin plastic tape, also used to make joints watertight by plumbers. So I'm just going to take a bit and wrap it around the thread end of the connector there. Now I don't want it to block the aperture at all, which might restrict the airflow, but I just want to get a nice thick layer around the thread end of the connector like that. Go around a few times, and once I've done that, I'm just going to use my nails to rip it off. And now when I take that connector and screw it down into this block, you'll find that that tape will just help seal up that thread to make that really airtight. You can tell if it's airtight or not. You'll be able to see the valve on the regulator, the needle going down to show you that air is being lost somewhere in the system. And also if you put your finger near a port like this, you'll be able to feel if any air is escaping. If it is, you can simply unscrew the connector, put a bit more tape on and then re-screw it down again. Now splitters are the simplest way to branch air from one line into several. You can get Y splitters, T splitters, multi-way splitters. If there is a port in a splitter that you're not using, you can push one of these blanking plugs into the end so that the air doesn't leak out of an unconnected hole. Now a valve is a simple switch which allows you to direct air from one port to one of a number of different output ports. A solenoid valve is an electronically activated valve, so rather than being controlled by hand, you can control them electronically, normally by supplying 12 volts or maybe 24 volts. And different types of solenoids give you different control. This one is a very simple two-way switch which either lets air pass through it or not. You can also get three-way valves which switch an air source between two possible outputs, which is the equivalent functionality of an electronic relay with a normally open and normally closed contact. You can also get four-way and five-way valves which allow you to do more complex push-pull control with dual acting cylinders. Now a manifold is like a splitter upgrade. It's a solid block with built-in solenoid valves, which can be controlled individually, so you can electronically direct air into each of the outputs, like a multi-channel electronic relay. And finally, your pneumatic system needs an output like these cylinders. These turn air pressure into motion. They expand and contract linearly like an electronic linear actuator. And they're not the only, but they're by far the most common pneumatic output you'll see used in props. Now, if you direct higher air pressure into the bottom port, they'll expand. Whereas if you have higher pressure at the top port, they will contract again. And you can also add these things called throttle valves onto the other ports that will restrict the rate at which air in the cylinder can escape, which means that you can make them expand and contract at different rates. So that brings me to the end of this introduction to the different elements involved in a pneumatic system. In my next video, I'm going to be looking in more detail at the different sorts of valve controls you can get and how you can wire a solenoid valve to a microcontroller to be able to automate a pneumatic system. So if you'd like to know more about that, please do like and subscribe to this video. Otherwise, you can check out any of the other video tutorials in this channel for more ideas of creative technology projects. Otherwise, I just want to say thanks very much for watching this video, and I look forward to seeing you next time. Okay, cheers, bye.